بسم الله الرحمن الرحيم والنجم إذا هوى ما ضل صاحبكم وما غوى وما ينطق عن الهوى إن هو إلا وحي يوحى علمه شديد القوى ذو مرة فاستوى وهو بالأفق الأعلى ثم دنا فتدلى فكان قاب قوسين أو أدنى فأوحى إلى عبده ما أوحى ما كذب الفؤاد ما رأى أفتمارونه على ما يرى ولقد رآه نزلة أخرى عند سدرة المنتهى عندها جنة المأوى إذ يغشى السدرة ما يغشى ما زاغ البصر وما طغى لقد رأى من آيات ربه الكبرى.
His Excellency Dr. Muhammad Al-Awhali, esteemed professors, honored guests, and respected engineers, it's our pleasure to welcome you all at the Future of Railway Transportation in Saudi Arabia Aspiration and Challenges Workshop, organized by King Faisal University College of Engineering. This workshop aims to build a clear understanding of the importance of developing and discussing the future of railway transportation in King Faisal University by gathering a wide variety of experts involved in the development of railway transportation in Saudi Arabia. We are honored to have our esteemed professor and the acting president of King Faisal University, His Excellency Dr. Muhammad Al-Awhali, the president of King Faisal University, to thank and award our respected speakers and participants. Please welcome to the stage Dr. Muhammad Al-Awhali.
بسم الله الحمد لله الصلاة والسلام على رسوله وصحبه أجمعين. الإخوة الحضور الكرام، ضيوفنا الكرام، الزملاء الأعزاء، أبنائنا الطلبة، يسعدني ضيفنا الكريم our honored guest Professor Cliff and other guests. يسعدني هذا الصباح مشاركتكم في هذه الندوة الهامة والتي هي بحمد الله تعالى تمثل أحد الاهتمامات التي تقوم بها جامعة الملك فيصل ممثلة في كلية الهندسة وبعض الإدارات الأخرى والكليات لتسليط الضوء على أحد المشاريع الحيوية في مملكتنا الغالية، هذه المسيرة التنموية التي ترعاها حكومة خادم الحرمين الشريفين الملك سلمان بن عبد العزيز يحفظه الله، وسمو ولي العهد الأمين صاحب السمو الملك الأمير محمد بن سلمان يحفظه الله. ما هو إلا تجسيد لهذا الاهتمام الكبير الذي نرعاه ونشهده في كل حين من مشاريع التنموية الكبرى والعملاقة التي تهيئ للمملكة العربية السعودية برؤيتها الجديدة ومستقبلها الواعد، وخاصة أنه أيضا يحقق أحد الأهداف التنموية للرؤية المباركة وأحد البرامج التحولية 2020 التي ترسم الطريق وتوضح معالم المملكة بالرؤية المستقبلية القادمة بإذن الله تعالى. وأحد المشاريع هذه مشاريع القطارات والربط التنموي الذي يمثل أيضا أحد القضايا المهمة في البنى التحتية والربط بين مناطق المملكة، وأيضا أحد الخدمات التي تقدمها هذه المسيرة المباركة رعاية للمواطنين والمقيمين في هذه أقول البلاد الشاسعة التي تمثل ربع تقريبا أو أكثر من الربع في القارة الأوروبية كلها. وإذا تحدثنا عن هذه القطارات وما تحمله من مساهمات ليست فقط كأداة انتقال، وإنما أيضا هي مساهمة فعالة في الاقتصاد الوطني وما ينبني عليه من كفاءة في التشغيل، وأيضا إحداث لتسهيل واختصار الوقت الذي هو أيضا أحد عناصر الاقتصاد. ومساهمة جامعة الملك فيصل في هذا الأمر ليست بغريبة، ومن كلية الهندسة أيضا ليست بغريبة. وأنا سعيد حقيقة بهذا الاهتمام الذي يواكب تطلعات الرؤية المستقبلية ويواكب الإحداث الأثر الذي ننشده جميعا لمساهمة الجامعة في مجتمعها وفي مسيرة التنمية لهذا البلد المعطاء. مساهمة الجامعة في هذا الأمر لأنه يجسد أيضا اهتماما بالشباب والكوادر الوطنية، أو بالأحرى أقول المواهب البشرية التي نسعى بجميع أنشطتنا وجميع أعمالنا البحثية والتعليمية والمشاركة الاجتماعية لتهيئة هذه الكوادر وهذه المواهب خدمة لهذه التنمية وخدمة لهذا البلاد الغالية. ولذا ليس بمستغرب أن تبذل الجهود وأن تحقق الشراكات المحلية والشراكات أيضا الدولية مع الجامعات ومع المؤسسات داخل المملكة مما لها علاقة مباشرة بهذه الندوة أو غير مباشرة، وكذلك أيضا مع التجارب العالمية التي دائما ننشد أن يكون أعمالنا لا تقل عن ما هو متوفر في الاتجاهات العالمية وأيضا في السوق العالمي. ولذا أكرر شكري لأهمية هذا اللقاء وأهمية هذه الندوة، ونحاول الخروج منها والاستفادة بأقصى ما يمكن وتحقيقها بإذن الله تعالى على مستوى البرامج التعليمية وعلى مستوى أيضا الأنشطة البحثية، ومن ذلك أيضا التعاون لتأدية أحد أهم أهداف أيضا مناشط الجامعة وهي الشراكة المجتمعية، وتحقيق كل ما يمكن أن يساهم في التعاون مع المؤسسات الحكومية وأيضا مؤسسات القطاع الخاص. لذا هنا يفسر سعادتي بهذه المشاركة واهتمامي بهذا اللقاء وترحيبي بجميع الضيوف وأيضا الزملاء والزميلات. اسمحوا لي بترحيب خاص بالضيف الكريم our guest Professor Cliff. It's an honor for us to have you here in our university. And as I indicated in my Arabic speech, this is an important aspect contributing to an endeavor, a new endeavor to create a real reflection of our new vision, Saudi Arabia 2030. And this transportation as an important tool, not only for transportation we consider it, it's an important tool to develop and contribute effectively in the economy. For this reason, we are very glad as a university and thanking College of Engineering for their activities and for working hard to make this happen. We are ensuring that this kind of activities, we would like it to be as effective as possible ensuring all our participants and our collaboration strategic partners within the Saudi Arabia and outside, and also ensuring that the collaboration with the international experience and international expertise like your STEAM universities and other collaboration and network is very important really to start from a very strong background and also continuous working to create the necessary activities to continue working in the three main activities, either in education and create the whatever necessary as a programs, and also in the research activities. We are very keen to have the real contribution for preparing our youth to make a real contribution to our economy, to our society, and for this reason we are very pleased to support and continue taking care of such activities, especially from College of Engineering, which we are very proud of its activity and its people, either in the faculty member or in student and also their staff. For this reason, I am very optimistic that this workshop will bring, inshallah, a very important, fruitful recommendations that it will give us a guidance to continue in this endeavor and make the real contribution. أكرر شكري وترحيبي وأيضا أشكر لجميع الفرق العاملة التي ساعدت في استقبال الضيوف وهيئت وسهرت لإحداث هذه الورشة، سعادة الوكيل الدكتور حسن وأيضا سعادة العميد والوكلاء ورؤساء الأقسام ومنسقين الأقسام وجميع الأخوة أعضاء هيئة التدريس وأيضا الموظفين، ولا أنسى الطلاب الذين أشكر لهم حضورهم ومساهمتهم، وأسأل الله لكم ولنا جميعا التوفيق، والسلام عليكم ورحمة الله وبركاته.
And now we will start to award our respected speakers, starting with the Professor Cliff Roberts. Please welcome to the stage. دكتور محمد قنفلة. انجينير محمد المرواني. انجينير ابراهيم تركستاني. انجينير منصور الأمين. انجينير عبد الله العوفي. انجينير ياسر حلواني. awesome. انجينير اياد القحطاني. And now we would like to thank our professor, Dr. Mohammed Al-Awhali. Thank you so much. Welcome Engineer Mohammed Al-Marwani to the stage from the Saudi Railway Company to deliver his speech about infrastructure for future railway transportation. Please welcome to the stage.
بسم الله السلام عليكم ورحمة الله وبركاته. اللهم صل وسلم على نبينا محمد وعلى آله وصحبه أجمعين. On behalf of Saudi Railway Company, I would like to thank you for the invitation for the future of the railway transportation in Saudi Arabia, aspirations and challenges workshop here in King Faisal University. We share our interest and we extend our support to this new railway research share that the university has started. And we believe that the way to have a sustainable railway network is by supporting this network with a research that focuses on finding solutions for the challenges that face the railway industry here in the Kingdom of Saudi Arabia. Railway was established here 60 years ago in the eastern province, connecting Dammam to Riyadh. And over the past 10 years, we have been expanding our network to connect mines with ports, with cities. And you know, the National Transformation Program 2020 have considered the railway as a major factor for the transportation or for the transformation, in which the Ministry of Transportation strategic objective number 8 is improve efficiency of railway to serve the 2030 vision and creating an attractive environment for both local and international investors. In addition, to establish a unique logistic platform across the 3 continents. In this presentation, we will take you on a journey to introduce you to SAR and its current network and the future plans, along with the challenges facing SAR and facing the railway industry in Saudi Arabia. With a fleet consists of around 500 wagons with 4 daily trips. Each trip consists of 120 wagons with 4 locomotives. Our monthly transformation of the phosphate, we have reached in the last months 452,000 tons in the last months, and we are aiming for more. In 2014, May, we have started our bauxite line, transferring bauxite from Ba'aitha mine to Ras Al Khair mine, driving roughly 500 kilometers to the mines related to Ma'aden in Ras Al Khair, with a fleet consists of 240 wagons with 2 daily trips, each with 110 wagons. In 2017, May, we have started our molten sulfur line, transporting sulfur or molten sulfur from Jubail industrial city to Wa'd al-Shamal city. For the people who does not know Wa'd al-Shamal, it's a city up north the kingdom, driving 1,400 kilometers to transport with a fleet of roughly 600 tank wagons and with a planned yearly transportation of 1.5 million trip. And in 2017, we have started our phosphoric acid line in June, transporting that phosphoric acid from Wa'd al-Shamal to Ras Al Khair port with a fleet of 562 tank wagons with a plan of 2.5 million tons per year. This is for the freight line. The main line right now we have in the media is the passenger line. In 2017, early 2017, we have started proudly the first stage of our passenger line connecting Riyadh with Majma'a with Qasim. And we are proud to announce the launch of the second phase or the second stage of the passenger line or passenger operation will be early next week, connecting Riyadh with Majma'a with Qasim, adding to that Hayy in 26th of November 2017. And our third stage to connect or to include Al Jawf and Al Ghurayat in the passenger operation mid of 2018. Up to now, we have transported 100 or we have served 135,000 customers in a round trip from Riyadh to Majma'a to Qasim. As a railway network for SAR owns a railway network with a 200 or 2,750 kilometers in length, with more than 200 bridges, 3,000 concrete culverts, more than 500 million cubic meter of earthworks, more than 4.6 million units of sleepers, more than 300,000 tons of rails. As for SAR, we have projects that are under construction, and we have a project or network that it's already constructed and it's under operation. As for the constructed projects, this is this map shows the network, which is famous with the North-South network or the North-South railway, connecting up north of the kingdom to Riyadh and Ras Al Khair. And for the under construction projects, we have currently 5 projects that are under construction. We have a project between connecting Ras Al Khair with Jubail Industrial City, and another project connecting Jubail Industrial City with Dammam. We have Jubail internal network. We have Ras Al Khair expansion, and we have Wa'ad Al Shamal network. This is for the current or the railway network that it's either constructed or under construction. For the part that's related to the future expansion for the kingdom, for the railway, and for SAR right now, it's the major 3 projects or the 3 mega projects. The first one, which is the famous known Jubail Jeddah connection, which is famous with the land bridge project, and the GCC countries connection, and Riyadh internal network, which is connecting SRO with SAR. This map shows the current and the future projects. In here we have from Jeddah to Jubail, Ras Al Khair, and Dammam, the land bridge project. And we have as a current the Haramain HHR and the North-South and the existing SRO line. And for the GCC is a planned, it's an under planned network connecting the cities or the countries of the GCC, Kuwait through Saudi to Qatar to Bahrain to Emirates through Oman. And this is up to now, this is the future or the expansion planned in the near future. For this part, the operational growth, I'm gonna leave you with my colleague, Engineer Ibrahim, to continue with these 2 parts.
Assalamu alaikum. Okay, I will give a quick introduction about the operation in the last 5 years. We started the first phase operation in 2011 with 2 trains back in Al Jawf. And right now we have 4 trains with 120 wagons. We delivered until this year 18 million ton of phosphate. And we started the bauxite in 2014, and we delivered until this year 9 million ton. And for this year, we just started the, the molten sulfur and the phosphoric acid. And we just delivered 130,000 ton from the phosphoric molten sulfur and 230,000 from the phosphoric acid. For the fuel consumption, until now, one of the aim of using the railway is to save the fuel and the emissions. So until now, we saved around 1.5 million barrels of fuel, which is equivalent to 25% of the total consumption of the truck. Also reduce the emissions, the CO2 by 75%, and the other emissions by 50%. Challenges. We know the environment here in Saudi Arabia. It's nearly desert, and we run the train in some areas in the middle of the desert, and this is a big challenge for us. So the maintenance profile with age has been changed. I will give an example. When you go to the OEM, for example, the OEM state that we have to overhaul the cooling system after 6 years. And because the harsh environment and the sand, so we had to overhaul the cooling system at 3 years. So we had to find our own procedure and activity and process. And supply chain. Most of the parts in the train are special design from the manufacturer. So we couldn't find it here locally. So when we want to fix or overhaul a motor or something, we have to send it back to the original manufacturer, which is takes around 6 months. Fleet failure modes. Every year we see different failures. Like 1 year we received failure with all the motors, sometimes with a cooling system, and every year we see different failure modes, and mainly because the sand and the high temperature. And also we have reliability issues with all the EC motors. For example, we have the AC motors. The OEM said that these motors last for 10 years. And right now, we only 6 years, and we paid around 30 million just for changing these motors. And to meet our customer demand, we just increased our fleet, our asset. We buy 36 new locomotives and 1,200 wagon. And these assets, when we increase the fleet, those new assets are under warranty. And still those assets, some of the locomotive or the wagon still failed and are new. So we have to go back to the OEM. When in the contract, for example, it's saying that if the same part it failed for 5 times, so this is the design issue. So they have to redesign the part or fix the problem. And we just introduced the new system, which is the ETCS system, the European Train Control System. It's mainly a safety system for run the trains. And developing the maintenance standard. We are following the AAR standard. And for example, when you go to the AAR standard, the AAR standard states that we should change the bearing, for example, in the axial of the locomotive after the second wheel change. But when we consider that, when we talk about wheel change, the wheel wear is different from US to Saudi Arabia. The second wheel change in US roughly at 2 million kilometers. But here, we are changing the wheels every 90,000 kilometers. So we have to develop our own standard. We have to look what we can do with the standard. And also with the developing the staff, we have our SRB college. Also, we are working to give them training, to develop the staff to work on the trains. For this part, I will leave it to my friend Muhammad. Thank you.
Thank you, Ibrahim. One of our challenges is, as you can see from the pictures, is the culture. We're facing a cultural issue with the fence, with the crossing the railway, and the pictures are talking. The other main challenge that we're facing is the environment. The biggest environmental challenge facing the railway in here in the kingdom is the sand. In order to better understand the challenges that the sand introduced to the railway operation, we need to have a general understanding first about the track formation. This picture gives us an idea about the track formation. We have the rails, then we have fastening system that connect the rails with what we call the sleepers, then transfer the loads to the ballast, then the sub-ballast, then the rest of the embankment. Sand accumulation affects all of that components, starting from the rails, by accelerating by reducing the wear or increasing the wear of the wheels and the rails, by affecting our fastening system, by affecting our sleepers, by damaging the formation. That's why it's becoming a challenge for SAR to face these kind of actions or behaviors that shows after having sand accumulation. As you can see from the pictures, total cover, we have also culverts totally covered. That's why it's a challenge for our operation and for our maintenance. Alhamdulillah, we're doing a good job by maintaining that, but we are interested in reducing it to a minimum standard. As a fastening system, which I mentioned, from the picture in here, you can see the wound fastening system. The sand presence accelerates the corrosion of the fastening system, and especially near to the coastal areas, in which most of our tracks or most of the ports are located. For you who does not know the fastening system looks like this. It's the piece that's connecting the rail with the sleepers. One of our challenge, which is a major challenge affecting both the rail and the wheel, what's called the wear. The wheel wear. We have abnormal friction that increases the wheel wear significantly. To give us more clear view of it, this is a part of track that shows fatigue and wears, and this is the idea of it. We have the wheel of the trains, and we have the rails, and the face, the wear or the contact between the rail and the wheel, it's causing the wear, and actually it's accelerating in here in a rapid way. And this is a major challenge also for us, for the rail itself and for the train, by changing the wheels. This is in general our challenges. We tried to give you an overview of our challenges. We're interested in finding solutions, and we're searching for solutions.
Good morning, everybody. My name is Mohammed Qurunfula. I work at Saudi organization, railway organization. I really welcome you all here in this event. I'm really proud to contribute and participate in such event. I joined SRO 2 years, almost 3 years now. Previously, I was in transportation field for like 5 years, and before that, I was in oil and gas company. I will prepare a history overview and then railway network overview. After that, passenger trains. Okay. Yeah. After that, we'll speak about passenger trains and freight trains. Unlike the people or my colleagues on SAR, we focus more into passengers than freight. Although our main concern is, one of the main concern is to deliver containers between Dammam and Riyadh. After that, I will speak about the future plans of SRO and strategic goals. All of us know that the creation of SRO has been an idea of Saudi Aramco company, which has been established by King Abdulaziz. And we have celebrated last year our 65 years of operation by putting 62 trips, 65 trip number 65, and also we have put freight trains with the 65 wagons. That's the current network of Saudi organization, railway organization. We have two lines. The main line is the line 1, which has passenger line, and then it contains double track between Hafuf and Riyadh. And we have single track for passenger and another line for freight between Dammam until Riyadh through Harad and the Tawdahiyya. That's, oops, which one? Yeah, that's one. Yeah. We have like total of 733 kilometers of line here, of track, due to the double track. 449 is the total length between Dammam and Riyadh. 449. And we have like through the line 2, we have 556 length, which is 556. I will tell you later about our strategic development regarding both lines. The new fleet of SRO. It's a CAF company, which we have a total of 12 sets, in addition to our 60, in addition to classic trains we have, which operates mainly between Hafuf and Dammam. We have 3 categories of seats in the trains. We have delivered last year a total number of 1,500,000 passengers between Riyadh and Dammam. And we are working on to increase that number yearly. The main challenge is limitation of the line, limitation of the scheduling, because you need to put positions for maintenance, and also the limitation of mixed traffic if you want to operate more freight lines, freight trains. We have achieved a total number of trips only for passenger 22 per day, mostly 11 in each side, and annual number of passenger is over 1,700,000, 3,000, and the total the time of the journey is 3 hours 35. Not all journeys have 3 hours 35. We have due to either express trains or normal trains, if it's going to stop in many stations, it will maybe take either less or more time. But the minimum number of hours that we achieved between Dammam and Riyadh is 3 hours and 20 minutes. The last year were like dramatic change have happened since the new president has took place in SRO. We have achieved reducing the journey between 420 until 4 hours 20 minutes until 3 minutes 35, even less, due to performance. I will show you later on what's the indicators that we took in our study to reduce that amount of time. Now I will speak about the freight. The freight, we have double stack, single stack, and in addition to some of the wagons that usually used in SAR to carry material or minerals. We have cooperation with them, and we exchange some wagon due to the demand of potential needs of the business itself. We have 800, 90% of our business or money generation into our freight is by the double stack containers. This yearly we carry from 500,000 containers to 700,000 containers yearly between Dammam and Riyadh. Still, there is a room of getting more of that sector because we are delivering not the whole Riyadh need of containers. That's the other parts of wagons that we have. The total wagon number is 2,591. Although, as I said to you, 840 are the crucial ones that we are using daily. We have daily 15 trips scheduled between Dammam and Riyadh for freight. Due to the demand, sometimes we operate from 5 until 15 due to the demand in the port, in the cement, in Algiers, in Sawami' or Saudi grains. Sometimes we used to carry military equipment between the port and the capital. That's one of the statistics regarding the number of containers we carry. The real challenge is to use the current ports efficiently because the limitation of space, and to increase more ports, yards in Dammam and in Riyadh. And there is already a new yard in Kharj has been developed to contain the empty containers. Okay, we have contributed into national transformation plan, and those our goals internally. We want to increase our efficiency and performance. Develop the surface, increase the safety, contain and expand passenger and cargo transportation, continue a full transformation into electrical transaction, pursue localization, which we have achieved a lot on that matter, and engage into a public sector, or have a PPP model. Infrastructure, upgrading. We have 250 250 kilometer re-innovated. This innovation is to allow us to do a mixed traffic between Dammam and Hafuf, as we have limitation of not having a double line, double track. So we want to utilize the area between Dammam and Hafuf to use both lines for passenger and freight. As we all know, passenger request more frequent journey within so little or very limited time period, mainly morning and afternoon, or before the duty and after the duty. And mainly we want it for the people of Hafuf or Ahsa, because we are delivering many of the King Faisal University students and back forth for Dammam University. And their opinion is affecting our timetable monthly. And that, you know, only people on railway know how that is not easy to do. When you affect your monthly timetable, you need to address that to regulators and get approvals and reschedule your freight timetable. And we've managed to do that. Still, demand and customer satisfaction need more, but we still want to develop in that area. That's the re-innovation part, re-innovated the track itself, create bridges to cancel the ground intersection. Increasing the speed, we have done that last year, increasing our speed to 160, but still limitation, because if you still have intersection within short periods, you don't reach to 160 and then go down. You cannot do that. Unless you close all the intersection and do bridges, then you get benefit out of the speed increase. The capacity, I will speak about the capacity later regarding our initiatives in NTB, the 4 initiatives. Fleet upgrading projects. We want to increase the goods, vehicles, grains, cement, limestone, which is very challenging to give them very good prices, and also to gain more from them. The challenge is to operate with less amount of money, and you have money generation container market. It's not easy, but we are like a public sector. We should provide those services. Maybe it's a different case for SAR, because it care most about the revenue. We have like 21 locomotives under manufacture and 480. Oh, sorry. 480 vehicles under still need to be given. The first batch is 150 locomotive wagon has been ordered and still in manufacturing phase. And then all of the 150 is the double stack containers. In addition to those container vehicles, we have secured 6 modern passenger trains sets. Those some figures regarding the containers. This one-way container figures, 237 from Dammam to Riyadh, and it comes back as an empty container, and 375,000 containers from Dammam to Riyadh. As we have participated in NTB, we have those initiatives raising revenue from investment of land, of general establishment of railways. We have done already that with consultants. We have signed last month a contract with one of the consultants to give us a good strategic plan or master plan regarding generating revenue out of the land bank. Enhance the capacity. Enhance the capacity, we have 4 projects under the enhancing the capacity. One of them mixed traffic between Hafuf and Dammam, longering the double the sidings to have 3 times the longer trains. And the third one is to increase the speed from 60 to 80 for the freight, and to buy more wagons to increase the capacity. Rising the operation safety, we have 9 projects under this. We have SMS and others plans. Safety, number 1 issue as SAR facing is camel. I don't know whether it's number 1 accidents cause in our organization. We have number 1 is accidents with the camels. It's crucial, it's dangerous, especially with the passengers. We don't have that much effect on the freight, but we still have a very big issue with the camel accidents. And it is very near now. The next couple of months, we have a lot of transaction of camels. Most of us in the railway prepared for that. The real challenge is this aspect, or this challenge cannot be found elsewhere in the globe. Still, there is the Australian people, they have problem with cows. Brazilian people also have cows, but still there is no very good solution to eliminate those accidents. Oops, sorry. Raising the safety, okay. Providing operation and maintenance, okay. We have this, the main objective or the main initiative that we are working now is to increase our capability of integrating into private sector, turning from public sector, as I spoke to Dr. Cliff before. British people has experienced that before, from transforming their railway to private companies. Still there is money to be subsidized, especially if you are talking about passenger trains, from the government, or you create source of revenue, as we added. The first one is land bank generation. One of the challenges that we faced, we used to have this in the top total number of minutes, daily 600 minutes, and that's only last year. This year we have this, which date is that, 22? Let me see, it's the day, yesterday. Yeah, yesterday. I took it from my email and I let the person put it, because I was involved in this matter, but now I'm not involved. I only received the email about the daily performance. We have like 21 categories of delays, and those attached to a department within our company, our organization. And whenever we have an issue with those minutes, we go and create a team, investigate, give a solution, and put it in the President, His Excellency table every week. We have achieved a lot since we've used this model. It gave us hard time in the beginning, because people find change, resist to a change, but after that, it's a very good method of managing your performance, passenger performance. Thank you, and I'm really glad to contribute and participate in such event. Thank you.
Now, we are honored to have Professor Kelv Roberts, Director of BCRRE, University of Birmingham, UK. I would like to invite him to the stage to deliver his speech about collaboration and area of collaboration and partnership with KFU Railway Chair. Welcome to the stage.
Excellent. Right. Good morning, everybody. Perhaps I should just say a few words as to why I'm here and what I'm going to speak about, and then I can start on the presentation. So I'm Clive Roberts. I'm Professor of Railway Systems at the University of Birmingham and Director of what's called the Birmingham Centre for Railway Research and Education. So I lead this group. It's the largest railway research and education group in Europe. In the UK, I also lead something called the UK Rail Research and Innovation Network, which is a cluster of 8 universities all working in railway research, and Birmingham and I lead that activity as well. I've been here since late on Saturday night to visit. It's my first time in Saudi Arabia. I've heard lots about the railways here. I had a really good understanding of what's been going on here, but I've never seen it with my own eyes. So I've been hosted over the last few days excellently by King Faisal University, with a view to looking at how I can help collaborate, me and my group can help collaborate with King Faisal University and the industry, the rail industry here in Saudi Arabia, to provide some knowledge transfer and increased sort of research and education capabilities. So my presentation is in that context. I'm going to talk through a little bit around just my university, so you know a bit about the university and see some pictures of trees and things. Then I'm going to tell you a little bit about the group and what we do on a technical level. I'm then going to talk through the education programs we run. We run an extensive range of education programs. We have over 500 students learning railway education with us, so explain how they work, and I'll make some sort of suggestions, propose some suggestions of the kinds of things that we might do to transfer some of those capabilities here to Saudi Arabia. I'm then also going to then talk around our research capabilities and focus on a few projects that I think are relevant to Saudi Arabia. I visited over the last 2 days. On Tuesday I visited SAR, and on yesterday I visited SRO. So I've had both times in the depot. So I've had quite a hands-on feel for some of the things that are concerns and day-to-day issues here. So I've tried to reflect those in what I've put in the slides. And then I've got to sort of conclude some initial proposals for collaboration. I should point out I haven't discussed those in detail with King Faisal University yet. This is just the opportunity to sort of share with you some of my thoughts of the ways that we may be able to collaborate. So my university is in Birmingham. Birmingham is the second city in the UK. The university was built in the year 1900 and was funded through money from the city to provide that was provided through the Industrial Revolution. You can sort of see it's about 5 kilometres out of the city centre there, and we're renowned for this freestanding clock tower right in the centre of campus. It's the I think there may be a taller one now in Dubai, but it was for many years the tallest freestanding clock tower in the world. For those of you who don't know where Birmingham is, it's about 160 kilometres northwest of London. We have a population of just over 1 million people. A train currently from London to Birmingham takes 1 hour and 22 minutes, but it has very good transport links. We have an international airport, and you may have heard that we are on the road to building our HS2, our high-speed rail network in the UK, and Birmingham is the centre of that network. What I mean by that is there'll be a line from London to Birmingham, and then there'll be a Y shape, for those of you who know the geography, one side to Leeds and one side to Manchester. So Birmingham acts as the hub of that network. We're a large multicultural city and a very young city, so 44% of our inhabitants are under 30 years old. So I'm letting the side down by making it a bit older. Here's just a few views. This is our new library on the top left. You may recognise this picture from your Microsoft screensaver, because Microsoft used this picture. This is our new shopping centre, the Bullring Shopping Centre, also used by Microsoft, the cathedral and various things. So it's an industrial city, but it's becoming increasingly pleasant, particularly with money on redevelopment that's been sent in the city. In terms of our university, we're a large university. I think we're the 4th largest university in the UK. We have around 34,000 students and 6,000 staff. We're 12th in the UK in terms of our research excellence. 64th, I updated this. I gave a presentation earlier in the week and I got the numbers wrong. So 64th in the world rankings. Of those in the UK, we're 10th. So we're in the top 100 universities in the world. Yeah, we're placed in various rankings. We're a good university, I guess it means. Now, the university is organised into a number of colleges. The college that I work in and my group is based in is the College of Engineering and Physical Sciences, and that in its own right is actually as big as one of the as big as a university. So it has 6,202 people involved in it, which is made up of a set of staff and a set of students with the numbers that you can see. And we do all sorts of things, but by far the railway group is the largest group in that college. But we also do work on chemical processing. We have a very strong chemical engineering department, civil engineering department, particularly looking at structures and geotechnics, work on computer graphics, wind turbines, all sorts of different things. And our university is an international university. We've been working very hard to develop specific strong links around the world. So we do a lot of work in China, but that's focused around our centre in Guangzhou, although we do work all over China. But for example, that's now enabled me to now have, I think I have 5 projects with Guangzhou Metro based out of that centre. We also have very strong links with the University of Illinois in Urbana-Champaign. They are a very strong American university, and again, in collaboration with them, I've developed projects with the Federal Railroad Authority in America and other companies. In Australia, in India, a lot in Singapore. I'll talk about Singapore quite a lot because the railway group has a very large activity in Singapore and in Brazil as well. So we're very keen to develop these sorts of international relationships. There's many more, but these are the major ones. And perhaps I just sort of share with you the university's strategic priorities. Basically, railways appear in all of them. So railways is seen as a very important thing for our university and how we can expand and do more things. And you'll see the last point that a key objective of the university is to grow research and education activities offshore. That means in partnership with overseas institutions and overseas industry. The particular focus in China, Singapore and Brazil, all areas where I'm currently working in my group, but I've also added Saudi Arabia because I think this follows a very good model of how we've been working with the kind of ways that the industry and the university requires here. So having given that introduction, let me then just say a little bit about my group. So the group at the University of Birmingham, the Railway Group, was formed in the 1970s. In those days, it was about 10 or 15 people. When I joined in 1997, we were about 25 people, something like that. Nowadays, we're 135 people and have a significant research income. £5 million a year in research income is a large number. We have a large number of undergraduate and master's students we teach in the UK and also in Singapore. We have 85 PhD students all working in railways. So this is all railway activities. We're strategic partners with most railway organisations, but perhaps of note, we're Network Rail's data integration and management strategic partner. So somebody was asking some questions earlier about how you can use the data that's collected to get more value from that and feed it back into asset management and decision making. That's exactly what we do for Network Rail. We're also the UK Rail Supply Group, so that's all the suppliers to the UK industry. We're their recognised centre of excellence for digital railway systems innovation. If I have time, I'll talk a little bit more about that as well. And then we work with all sorts of different partners, from IBM, from their base in San Francisco, on railroad data, so that brings us into the American and the international rail industry. And with Unipart, who are a large UK company that help railways deal with supply chain issues, and our local railway companies, we provide innovation and research to them, both by doing things in our labs, but also providing placements for our students, seconding our research staff into particular problems that they have, helping on particular projects. I shouldn't really tell you this, but I don't think you'll know anyone to tell, so I'll share this with you. So every 2 years, the Queen awards a medal, a prize for research, and on Thursday we will be awarded with this prize. So I'm going back to London and then I go off to Buckingham Palace on Thursday to receive this medal for the work that we've been doing. So it's a very, very important prize, and I and my university is very excited about the work we've been doing in railways and the fact it's going to be recognised by our Queen. And then internationally, we do all sorts of different things. I said I'd mention Singapore, so perhaps I should mention that here. About 3 years ago, I had a similar visit to Singapore. There were less sand and less camels, but equal sort of amount of heat, and a similar sort of situation in the industry, where there was a growing rail industry, a desire to produce more capability and grow the networks in the future, but the universities had a very limited sort of experience in railways, and the industry wasn't really providing long-term railway education or had an R&D plan in place. So from 3 years ago, we've now worked with the Singaporean government, the Singaporean railway operator, and also some of the universities there, and we've developed a number of things. So we've developed a postgraduate program for railway staff that now 251 students, 251 members of the Singaporean railway industry are on our program, that we at the moment go and deliver in Singapore, but over a 5-year period we will stop delivering it and local people will begin to deliver that program. So it will become owned by Singapore. At the moment we're in year 2 of this, so at the moment there's still quite a lot of us going and delivering activity, but in 5 years' time that will be owned fully by Singapore. We also have a number of research projects, again collaboratively with local universities. So this year alone we've started over £1 million worth of research projects shared between ourselves and the local universities. And I also serve on the board of Singapore Metro and I'm one of their technical advisors, and actually I go quite a lot nowadays and ended up doing TV interviews and various things to explain why railway problems happen. And a couple of weeks ago they had an accident and I had to record a thing for the television and various things. So we're embedded in Singapore. The kind of relationship that I might be suggesting here is not the same, but it gives you a flavour of the kinds of things that we're very happy to do, we're very keen to do. But for me, it's all about being able to provide knowledge transfer and build capability in country, so that in a few years' time, if we come and help collaborate, in a few years' time we can go away again, and there's a residual capability here that we've helped develop. And from our university point of view, we're not a company, we're a charity. From a university point of view, this is all about being able to create global impact and leave a lasting capability. So it fits with our sort of ideas. We're doing similar things but different in China, in America, Japan, various places around the world. And what motivates me and my group, we obviously are good researchers, we come from a good university, but is doing things that are practically applicable to railways. And there's nothing better as a university researcher than being able to travel by train and look out the window and say, I had something to do with that, I did that work, or my group did that work. So that's really what motivates us. So we have a long-standing education activity at Birmingham. For 22 years now, we've been running an MSc program in Railway Systems Engineering and Integration. For the first 10 years of its life, it ran at the University of Sheffield, and it was a collaboration between many universities in the UK. At that point, the University of Sheffield decided it didn't want to work in railways, so the whole activity moved to Birmingham and enabled us to grow our group. That course, I'll say a little bit about it in a minute, but that course really runs a bit like a technical MBA, and it's the basis for quite a lot of our education that we do in conjunction with industry. So that course is aimed at providing what I would call T-shaped people. So people that are at a management level and have a really good understanding of all aspects of railway engineering, and then they have their specialism in one particular area. So you get the T, which is the breadth, and the depth is provided by the skills they have in one particular area. I have a diagram to show this later. But that course is now we have about 700 or 800 alumni around the world having gone through that course. Certainly there's people in the Gulf area that have done that course, and they hold senior positions in many railway organisations around the world. In 2013, with support from the Chinese government, we started a new MSc in Railway Risk and Safety Management, and that course was specifically designed to address issues around risk and safety culture in the Chinese railway system. And we started a course with Zhejiang University in Hangzhou in China, a good university, and helped them develop a railway capability there. But we also run a sister program in Birmingham, so we run the same program in the University of Birmingham. That course is much more rounded in the area of trying to address risk and safety, trying to address where, understand where those are important in railways. And then in 2014 we started undergraduate programs, so they are 3-year or 4-year degrees in electrical and railway engineering and civil and railway engineering. And one of the things I'll come on to later is that we have an exchange program with those courses already with Beijing Jiaotong University in Beijing. I'm a visiting professor and run a lab there as well. With them, they send us some students who join the end of our program, and they graduate with degrees from both universities. So there's a potential to do similar things here. We also have a Masters in Research program, which is less classroom-based and more research-based. And we also have plans to start new courses, one in railway control and communication systems and one in railway asset management in next year. We also have something called the National High Speed Rail College, which we're a founder member of in the UK. I have a slide on that, but that's for post-18 education currently, and we're supporting the curriculum of that college. So that's about technician level education in railways. And then we run all sorts of different CPD courses. I think the only thing, and we do that in Birmingham, or we travel to do that. I think the only recollection I have of doing a course in that sort of area is we did a course in Oman maybe 2 or 3 years ago. So this is just some of that in a different slide. And this is what 170 Singaporean railway students look like, and just to remind me to tell you how we deliver these programs in Singapore. So what happens in Singapore is I think about 13 of my staff go over for a few weeks each year en masse, so I usually go with them. I was there 3 or 4 weeks ago, and we deliver very intensive education to the staff in the railway companies. They are the staff in the railway companies. And then after 3 years, they get a qualification from the University of Birmingham. That's not the only way of delivering this, but it's the way we do it there. The more senior members of staff and people from the universities also attend those lectures. And the idea is that after a couple of years, we will stop sending quite so many people, and they will be delivering more of the lectures themselves. So there is a knowledge transfer and, as I say, an ownership of that course transition between where we started from and where we're getting to. Right, so I'm talking about lots of different courses, and those of you who haven't spent lots of time in UK universities may not quite understand the mechanism, so I thought I'd perhaps this diagram up before I go any further. In terms of education programs, we talk about MSc, and how that works is, so this is a postgraduate program. It's 2/3 classroom-based, taught-based, and 1/3 dissertation project-based. We also run an MSc by research, which is entirely project, so that's a bit like a first year of a PhD or an MPhil. And we also run a Masters in Research program, which is 1/3 taught and 2/3 project. And then there's a PhD, which is this large block of 3 years. All these master programs you can do in 1 year. So we run programs of all of these kinds for railways at Birmingham, and we have ways of slicing and splitting them up so that they can be exported and taken away. So to give you an example of that, this course that we've been running for 22 years, the Railway Systems Engineering and Integration course, I'm not sure whether you can read all of those, but it has 8 modules around it. These are taught in 1 week intensive blocks. So they can be delivered as CPD, so continual professional development courses. People can do all of them, or some of them, and get half a qualification. They can put some of them into an MRes, some of them into an MSc. They can do all sorts of different things with them. And remember, this is to do that breadth. So there's a module on strategic management of railway operations, one on rolling stock system design, one on traction system design, one on systems engineering and integration and dependability, one on railway infrastructure and track systems, one on railway control systems, so signalling, one on railway business management, and on ergonomics and human factors for railways. So to get the MSc, the students do all of those and a project, but people come, so for example, people come from Singapore and just do one of those modules. They come to Birmingham to do them. Or equally, we can, as I say, slice these up and put them into different settings. And similarly for the railway risk and safety management, this is much more focused on risk and safety areas. So there's, additionally to some of those areas I've just spoken about, there's work on railway system management systems, on computer and safety assurance in critical systems, through life safety assurance, and then all the engineering modules as well. And then I mentioned the National High Speed Rail College. So in 2016, the government announced that it would provide funding to cities to build a national college for high-speed rail. Birmingham grouped together, which was our city council, one of our further education colleges, and also my group at the University of Birmingham, and we jointly bid to get this money from the government. In the end, the government awarded two colleges, one in Birmingham and one in Doncaster. And the college opened this year in 2017, the one in Birmingham, and eventually, at the moment it's got 150 students, but eventually it will have 1,100 students a year going through that college. As I said earlier, we've been developing the curriculum for that, focused mainly on post-18 education, so this is students who have done extended study at school but don't want to go to university, so educated technician level. And again, this is an important part of the education beyond the university sort of undergraduate and master's level I've been talking about. Right, my first sort of summary, I guess, is that there's potential for us to work together on 2+2 undergraduate programs, on 1+1 master's programs, on us being able to develop some intensive courses here in Saudi Arabia to fit in existing courses, or for industry to develop, to have short courses, executive level training, for people to come and attend modules in Birmingham, for us to run a course in Birmingham to help train staff here to be able to deliver things, for PhDs to be undertaken in Birmingham, and also for split location PhDs. So we have a mechanism where students can be awarded a PhD from the University of Birmingham, but they only spend 6 months of their study in Birmingham and the 30 months of their time in their home institution, i.e. here. So there's some things, if you like, in terms of the things that I've been thinking about while I've been here, that we might be able to start as mechanisms. All of them maybe, but probably not all of them, just one or two, a sort of menu of things that might be able to help. So now let me talk about the research activities. We have a broad range of research activities. I'm going to talk about most of them a little bit later on, but I don't have a slide on the international benchmarking one, so perhaps I will talk a little bit more about that on this slide. So 3 years ago, we appointed what we call an industrial professor. So this is not somebody who's worked in academia, but they've held a senior role in industry and then want to move over to academia. And we appointed Professor Jack, who up until that point had been the Chief Operating Officer of the Railway Safety and Standards Board in the UK. So that's the organisation that looks after all of the standards, writes the standards in the UK, also helps sit on many of the international committees. So for example, Anson sits on the International High Speed Rail Association committee and represents the UK on that, albeit now he works in the university with us. But that work is developing work on international benchmarking, on governance, which particularly picks up with some of the things that people here have mentioned about privatisation of railways. So Anson worked extensively on the privatisation in the UK, also on safety issues and systems issues. So that's another area beyond the things I'm going to talk about. So in the area of operations simulation, we do a lot of work on modelling railways and traffic flows. We have our own simulator, which enables us to put hardware in the loop, or people in the loop. So this enables us to develop, for example, this bottom here is an AGV simulation test rig that we've built ourselves at the university. We're able to build train simulators that attach to this. And this simulator enables us to do the kinds of things that normal driver simulators do, but to interact with actually hardware. So maybe brakes or traction motors as well in that loop, maybe parts of the signalling system. We can put all of those into a laboratory environment. One of the things that I think might be interesting here is that we can model lines and look at different timetables. We can look at the effect of running one timetable and then putting delays on it. So for example, if you had a timetable that was a passenger freight timetable, an interrunning timetable, and you then started to look at putting freight delays in or extended dwell times at stations, you could then see what the robustness of that timetable was under failure. And providing the same service pattern, what you're able to do is optimize that timetable so that you get something that can cope with failure better than other types of timetables. So we've shown through research that if we take a timetable and we improve it, we don't change necessarily, well, we don't change the amount of services, we change ordering of trains and things like this, and then we can get a timetable that can cope with delays much better. I.e., if there's a delay, not everything stops and the whole network grinds to a halt. We can cope with something that carries on working to some extent. So this is just a quick video of that simulator. It won't mean a lot other than you believe it exists now. So this is a simulation of the East Coast Main Line in the UK. Down the bottom here is London. There's about 160 kilometres of railway modelled there. Each of these little white things that you see moving on the screen is a train, so it's a very busy network, a headway of about 3 minutes on there. And then this model's right down to signalling level, so the things you can see flashing on the spreadsheet-like things are the signals, the track circuits, the points moving, the routes being set, and we can model all of that in exactly the right way. We can do that with ETCS as well as with fixed block signalling, which this is. And we can therefore look at the effects that has. We have a power module that sits on the top of that, so we can do energy analysis and power systems analysis with that. We can also do GSMR modelling, so we can do comms modelling on the top of that. We can also do people modelling, so if there's people coming off one train and then they have a connecting service and they get onto another train or get onto a public services, we can add to this those sorts of simulations. So that's all about simulation. On top of that, we can then, I've hinted at this already, we can write algorithms that can take automatic control or provide decision support to operators. So we have a capability to be able to use our knowledge to look at scenarios in real time, use a computer to look at scenarios, and then when things start to deviate from the planned strategy, a new strategy is suggested. So that's the decision support, or in a very, very busy railway, you can automatically take control of the trains and the computer just tells the trains what to do. We do a lot of work on condition monitoring, so instrumenting pieces of the track. This is for points monitoring, instrumenting the train to look at the track. I'll talk about a couple of examples of that later. Work on power and energy optimization to look at new types of traction methods. So for example, I'm currently doing work in Canada to help them look at whether they might use hydrogen-powered trains for a particular part of their network. We also model power systems, so in Singapore, they have a DC electrified railway. They have lots of problems where under certain circumstances, with certain climatic issues, the power system fails. So we've been modelling that, and now we've identified what the problems are in the model, and now changes are being made to those parts of the network in Singapore. But predominantly we do work on helping railway operators to drive trains better, so they use less fuel, they don't have so much rail pad wear, so we can extend the life of the railway components through driving, whilst also saving money on energy. And I have a couple of examples of that later in the suggested projects. In this area of data integration and cybersecurity, lots of work on big data. In Britain, we have something called the Digital Railway. It's a third of Network Rail is now working on the Digital Railway project, which is to upgrade and revolutionise our main lines. We're the chief research provider into that, and therefore we're doing lots of work in this area of how we use data better, how we not just collect data, we turn it into information. We then can turn it into knowledge, which then informs how we run our railway into the future. So not just collecting the data, actually making some use of it. We do a lot of work of aerodynamics, and this is where some sand issues are interesting actually. So we do a lot of work on high-speed railways, but we do work on, for example, looking at ballast flight. So how, as we go over high-speed railways, so for example in the UK on HS1 at 300 kilometres an hour, we get particular issues about the underneath design of the train that lifts the ballast up. And if you happen to be a worker working on the track, people have got hit by very fast moving, it's like being shot by ballast. I think there's lots and lots of synergies with some of the sand problems with this. So one of the things we've done, this instrumentation here on the left here, is a device to look at the slipstreams underneath the train to see what type of trains lift ballast and which types of trains don't. So we've got now an understanding of the kinds of things that you can do to the underneath of the train to make sure you don't disturb and lift ballast. I should point out my background is in electronics. There's another part of my group that does this, but my thinking is that this kind of modelling and understanding, which is computational fluid dynamics type modelling, would apply to sand, and there's probably things you can do to the underneath of trains to stop sand lifting into the wheel rail interface, stop it lifting into the traction systems, etc. So I think there's some interesting lessons to be learned around that. The kinds of things that my team do in this type of modelling and experimentation would also apply to putting barriers around bits of track. Again, a different example, the same sort of mathematics though. The middle picture here for our HS2 network, our high-speed rail network, we're doing the tunnel portal design for the railway. What we are looking at is crosswinds. So as you get a train coming out of a tunnel, if you have a crosswind effect, how that buffets and affects the train. Similarly, the kinds of maths that we use for that and the models we can use for that could look at sand crosswinds and the effects of those. We do a lot of work on climate change impact and adaptation. Not usefully for you, we do lots of work about freezing weather. You don't need to worry about that. So what we do is snow and build up of snow, those sorts of things. But we also do work on heat. And in the UK, that's about temperature differential. So we suffer from rail buckling because of the low temperatures that we have to experience and the high temperatures that we have to experience. And again, it's a transition in terms of temperatures, but that sort of approach must be relevant here. Lots of work of computational modelling of all sorts of different railway components. So some of the pictures here you can see of switches. We've developed a model for Network Rail that's used to improve their switch design and actually now counts for the safety case for doing that. So instead of having to do experimental changes, we can do all those changes in the simulation, and the railway inspector believes our simulation, so they can just then make the changes on the railway. And also work on track modelling. This is not a particularly good graphic, but we have full finite element models of tracks and lumped element models of tracks. And one of the interesting things I think around this that I'm observing here is that you have ballasted track, but it all fills up with sand, so it actually probably presents a bit more like a slab track. What that effect is and how ballast degrades. And although we do some of that modelling work at Birmingham, and I'll come on to how we work with others, but at Southampton University, I do lots of work with Southampton University. They do a lot of work on ballast degradation. I'm sure there'll be researchers there that are interested in these sorts of problems. Work on metallurgy and non-destructive testing. This is mainly looking for cracks in rails, microstructural cracks in rails and in wheels. So we've done a lot of work on ultrasonics and eddy current type inspections and being able to do those in a much more effective way. So in the UK, we use slow 50 km/h ultrasonic inspection trains. We've proven that we can do that sort of detection at 160 km/h now. We've also shown that we can, when a crack's detected, we can send robot trolleys out to look at particular cracks rather than people, and there's some benefits around recording and configuration management for that. And then work on geotechnic engineering. We have this laboratory here, you can see on the bottom left here, which enables us to provide a 25-ton dynamic axle load to a track section. And in this instance, there's a cable duct next to it, and we're observing the effect that we would have. We'll have built this in a model, but then we build this up in the lab and see whether, if we we can pretend that this can emulate trains going through, we can see what the effects might be over a life cycle on that particular piece of infrastructure. So we can do extended life cycle testing, and we do a lot of work on water and flooded areas. Again, this pit can be sort of dug out and we can build up the substructure in the laboratory of anything we like. You could do that with a nice sand mix and do various things in it as you were doing it. So, in terms of the suggested collaboration objectives, this is, perhaps I should have put this earlier, but the overall objectives that I can see is that we will be able to support the university in developing and delivering railway research and education across those sorts of areas that I've talked about. I'm very, very keen to facilitate that knowledge transfer. So for me, it's all about trying to put a process in place to get some of this thinking into local people here in Saudi Arabia, rather than us just coming and doing stuff and then going away again. For me, everything has got to have an end point of knowledge transfer. I think there's 4 high-level things, and I'm going to go on to some specifics in a minute, There's 4 high-level things that I think I've picked up in general through my discussions. One is to try and improve or build the fundamentals of understanding of failures and key events that happen. So I've observed that there's lots of things happening out there that perhaps are a bit different, and people say, well, that's because of the sand or whatever, but the fundamental, or the heat, the fundamental understanding isn't there. So, and that's just because of bandwidth of time and effort. Everything's been focused on getting things up to speed, as I think somebody said. But so, for example, wheels aren't lasting here very long here. We sort of know why that is, but in detail, why is that? What is it we could actually start to do that? So fundamental understanding of that. Things like traction motor failures. Traction motors are being replaced here every 2 years. In the UK, I'd expect a traction motor to last 10 or 15 years. We know that's probably because of the sand ingress and the heat, but what sort of things can we do to try and improve that rather than just cope with that? And those, remember, well, you know well, those failures, those issues are probably causing some kind of in-service failure, so they're causing a punctuality issue. They're also costing an awful lot of money. Those things aren't cheap to keep replacing and maintaining. So there's a punctuality issue and a cost saving here. I think as new railway goes forward, then having a more in-country understanding of system impacts of design choices. So I think that's got to be a long-term objective. So again, so the reliance on external consultants is sort of much more a collaborative approach with expertise here in Saudi Arabia, and that's about understanding all sorts of different system issues. I think on the SAR network I knew already, but I was told that there's some interesting things about the inclination of the rails which potentially causes some issues, and those sorts of things maybe could have been picked up if there had been more understanding around those sorts of things already. And then refinement of maintenance philosophy and end-to-end asset management. So there's a lot of work that's been done on scheduled maintenance processes, putting those in place, but more on condition type work and this tracing of components through to that end-to-end management of assets. I think there's, that's the next generation of beyond the kinds of things that are going on here at the moment. And then this idea of risk-based decision-making based on evidence. So again, my observation, bear in mind this is done over 2 days but my observation is that there's lots of things that are being done because it says so in the standards, and maybe there's potential to actually put some more science and thinking behind that to be able to challenge some of the conventions of how things are done, either to improve life, to improve punctuality, to save money. So this is all about building fundamental understanding and capability so that some of these questions can be addressed and answered, which will improve both new railways being developed, but also the cost effectiveness of the existing railways, and start to really focus in on specific problems in a scientific way rather than an operational strategy way. So I've come up with some different projects that some of them I might breeze over depending on, I've got a little bit of time. So I'll try and talk through most of these to give you an idea of the kinds of things that I think would be interesting projects that certainly would build on our immediate capability at Birmingham. So things we've done already that we could package and sort of allow to happen here with a little bit of input and mentoring from us. So there's work on timetabling. I've sort of suggested some of that already. Passing loop placement. So we've done a lot of work on looking at the optimal length of passing loops and where they should be. Work on switch condition monitoring and measurement. So looking at switches and crossings. Work on loco and wagon health measurements, bearing condition monitoring, wheel set investigations, energy efficient running, computational modelling for all sorts of different things, and track geometry measurements. So I think I've got 1 or 2 slides on each of these areas, and there's a longer list. So here's some other things that I don't have slides on just because I don't have the presentations with me. So work on benchmarking of key performance, key components. I'm very interested that I've mentioned some numbers, and you know the numbers better than I, about how this life works, but there's life shortening, but there are other parts of the world that have not necessarily directly the same, but similar climates, so bits of America, other bits in the Gulf region, supporting work around benchmarking of those and how you'd actually understand whether those experiences are actually being are the same in other countries, but they're just being managed differently, or whether you just have some unique experiences. Sound effects, I've talked about track modelling and computational fluid dynamics and how some of the work we've done there could transfer. Work on wheel-rail interface optimization. I think this is a longer-term thing, but looking at where that should get to. Work on supply chain optimization and perhaps supporting the supply chain, particularly for SAR, where things are being sent out of country for overhaul, and maybe there's a motivation to do some of that in country. How does that happen? I've added this one as we've been talking today about radar detection. So we've done a lot of work on detecting cars at level crossings, where they get trapped on level crossings. I think and doing that from a moving train. I think you could probably use the same technologies for camel detection. So using radars on the front of trains to look for camels. Work on corrosion analysis. One of the experts in my group works particularly on rust and corrosion, so there's some things there. Work on in the lab for adjusting our lab conditions for high temperatures, humidity and sand, and this area of governance and organisation of the industry, and particularly the expertise that Ants and Jack in my group has around this area. So let's just talk a few of those technically. So the work on timetabling, we've done a lot of work with Network Rail to look at how they can make their timetables better. And bear in mind that they're very, very high capacity timetables. And what we have, you probably can't see this, but down the bottom here we have all the things that we can change on the railway. So they're the physical things on the railway. And up the top, they're all the things we might measure the railway by. So journey time, potential for delay, energy usage, all of those sorts of things are at the top. And what we can do in the simulations I showed you is change these things down the bottom. So let's say if we manage delay better, if we manage the dwell times better, if we speeded up the acceleration of the train, we drove the train differently, all those sorts of things, how would they affect the running of the train? And we can then take all that forward through to timetabling. So in long-term plan timetables, we can present a number of different timetables to this simulator and then measure the effects of those timetables, how they run, and we can measure them under potential delays, and that enables us to look at this robustness issue. We can also do this in real time, so if there's an unseen circumstance occurring, maybe a train's broken down, we can then start to look at what the optimal operational solution might be. So whether that's to cancel trains and end them earlier, reroute them, try and do other things with them. So we can look at those. So we have this capability within the simulator to do that. Similarly, we can do work with this idea of passing loops. So we can take existing passing loops and model them in the simulator, and then we can extend those loops and put them in slightly different places. And so, for example, this loop here, we can decide whether we want to extend it 2 kilometres south or 2 kilometres north, and we can look at the operational improvement that we would get by doing that. And again, we can see what flexibility and robustness we'll get in the timetable by doing that. We've done a lot of work on putting instrumentation on switches with a view to detecting and diagnosing faults. There's now 9,600 sets of points in the UK running our system, and there we're putting some simple sensors on, and we can now predict about 60% of faults in advance of them occurring. So we're sending out staff to repair a set of points before they actually fail. The initial work was on fault detection, i.e. saying there's something wrong. We then did work on fault diagnosis, or saying what the failure mode was. And nowadays we're doing work on fault prognosis, being able to say it's going to go wrong in a week, or it's going to go wrong in 3 weeks, or whatever. We also have work on switch measurement. So I think I saw some issues around this at SOR yesterday. So this is using a laser-based system to measure the gauge of the switch, particularly after work had been done on the switch. This is now being turned into a product. It's research we did at Birmingham, and this is the research version. There's now a product version of this. But the idea of this is to provide a 3D geometry of the switch, and this makes sure that the gauge is right, the rail shape is right, and removes the needs for those handheld gauges that people use. We have had a lot of problems at slow speed switches where people have done maintenance work and then opened the switch, and then first trains through have derailed. I saw a video of something similar yesterday here in Saudi Arabia. This is the mitigation that we've developed for that. We do a lot of work on instrumentation, and we've developed these nodes that can be distributed over the network. But probably more importantly from the things I've seen here is we can use the similar things on trains. And these are temporary monitoring systems. They have energy harvesting. so they don't need any power, and they have an ad hoc communications network, so they don't need any comms fixed wired links, and you can just place them on the train temporarily to understand the health assessment of the train. So we've done work in America and also in Germany with loco overhaul companies, where they do work and then they want to be able to show to the customer that they've repaired something. They can do a before and after test, and we can gather the data to prove that there was a fault and help diagnose the fault, but then afterwards that they've actually repaired the fault and it's better than it was. So it can be run up the track for a couple of kilometres, run back again, and the evidence is there that work has done. It's looking at things like traction motors, bearings, gearboxes, those sorts of assets. It would strike me that there's sort of an interest in those sorts of things here. So it's a temporary system. We've also done a lot of work on trackside bearing monitoring, so looking at bearing faults, and this is to move from our bearing overhaul at 800,000 kilometres on some of our passenger services to 1.2 million kilometres between passenger services. And what was happening in our standards, similarly to yours, in our standards it dictates when we need to do a bearing overhaul. And we were doing a lot of bearing overhauls where we weren't finding any problems. There's a risk if you're actually opening bearings up that you actually do more damage than if it's perfectly fine. There's no need to look at this. So we've then moved into this acoustic monitoring approach specifically to look at overhaul. So there's two ways of doing acoustic monitoring. You can do it just to look for faults and you pull out exceptions, or the way we've done it, which is a more advanced way, is you look for particular failure modes and then you focus in on those failure modes. So we've developed this acoustic system that sits at the side of the railway line. We've developed it for high-speed rail, but actually we practiced on freight wagons before we took it onto high-speed railway. And we're placing it on a section of track where trains are running through at 200 kilometres an hour. You can perhaps see this. So there's some sound, but you won't be able to hear it. So here comes through our high-speed train at 200 kilometres an hour. This is our instrumentation here, and what we have is an array of microphones and a camera. And so the camera's looking at the bearings. So as the trains go past at 200, it's a very high-speed camera, it's an expensive camera. As the train goes past at 200 kilometres an hour, we identify where the bearing is. And then if you can imagine this in slow motion, here's the bearing. We then basically adjust the microphone balances at very, very high speeds as that bearing goes past. So we're focusing in on the bearing, and the bearings are, the microphones are placed at a particular height for the bearings, so it's all optimal design. It took us about 2 years to work out how to do this. We can therefore look at this and pick out bearings that have failed. And we did this work with Hitachi. Hitachi said they would send us 300 trains through, or 300 axles through, and they knew one of them had a fault on it. And they wanted us to tell them which train had the fault. So it was a blind test from our point of view. If I'm honest, we were a bit surprised whether we would be able to do this or not. We'd never tried this before, but the science said it would work. But you can imagine what we're listening for. There's a huge amount of noise going on there. And what we're listening for is a noise of a bearing, and the noise of a bearing that you wouldn't hear with the human ear. It's a scratch or an outer shape roller on the bearing. So it's a fault that hasn't initiated a hot axle box detector or registered anywhere as a fault. It's a fault that we just happen to know that. And I'd be building this up wrong if I then said we couldn't do it. But so we could do it. So we were able to pick out of our 300 bearings the particular train that had the fault and which particular bearing that had the fault. So this again is something where we've really sort of extended the work in this area. We've also been doing work on robotics for wheel set inspection. For this is looking at, instead of using humans to measure wheel set wear, to use robots to do that. And we have a particular rig at the university where we're developing these techniques, and it does non-destructive testing of the axles and the wheel set, and also sizing of all of these sorts of things. And again, this provides into your asset management system a detailed configuration management area, so you know exactly what you've measured and why and when. Right, work onto powering and energy optimization. I showed you one of our operations simulators. We then have two energy simulators. The one that would be most relevant here is actually the simpler one of the two, which is the single train simulator. So this is something we've written ourselves. It's written in MATLAB, but it's now used all around the world. So Indian railways use it, London Underground use it, Network Rail, Singapore Metro, Who else? They use it in Kuala Lumpur, various people around the world, MTR, Singapore. And what it does is it's moderately simple, but it provides a simulation of a train moving from A to B. And you put into it the characteristics of the train, so the tractive effort, the Davis equation, so the aerodynamic effects of the train, the mass of the train, all of those sorts of things. And you put in the gradient of the track, and you move, in the simulation, you move the train from A to B. And what it tells you is you put in some driving strategy. It tells you, given that driving strategy, the energy that the train would use. It's very quick. It works that out in half a second, less than half a second, for a 100-kilometer journey. So then what you can do is you can then put that into some kind of optimization loop, something called a genetic algorithm is what we generally use. If you don't know what genetic algorithm, don't worry. Just something that runs it time and time and time again in a particular focused way to find the best solution. So we can run that simulator time and time and time again, and therefore find the optimum way to get from A to B that reduces the amount of energy. We can also do it on electrified railways where we don't want too much power draw to also with some constraint about power demand, but you don't need to worry about that. So we can then optimize a driving strategy from here to here over the 100 kilometers journey that will use the least amount of fuel. That means you can then either provide that into some kind of screen to the driver, and they just basically follow the commands. I noticed on the locos I saw at SRO yesterday, there's an 8-handled notched position. We've done something similar with a 4-handled notch position, where we basically just tell the driver what notch position to drive the train in, and they try and follow that, and it enables them to drive the train on an energy efficient way. Or we can give the drivers training. So in Edinburgh Tram, for example, what we've done is we've saved about 80. We can get about 80% of the energy savings because it's a small network just by having the drivers in a room. We explain to them how they can drive and it uses loads of energy, how they can drive and it uses a lot less energy, and we've recorded them before and after that training and reduced. We've got 80% of the optimal level. So these numbers are small, but you'll scale up. So for Edinburgh Tram, where we have the most traceable benefit of this, they use about £1 million of electric to power their trains a year. It's a small network. We've saved 16% of energy by just training their drivers to drive better. That's not any clever system. We've done some simulations and then had their drivers in a room. And so out of £1 million, we've saved £160,000 every year by getting their drivers to drive better. If you go into a more automated system, you can get more out of that. So this is some of the work we did on a similar lane type with Merseyrail. This is the kind of train with the 4-notched position, so it's quite an old-fashioned train, like some of the locos that you have. And down here we can look at the different energy comparisons and speed journeys. I happened to notice when I was in SRO that quite a lot of the data that we needed for this, and we had to build a specialised measurement system you already have from a train download. So it's actually possible for us to do that analysis from some of the data I think you already have on your computers and provide an optimal training and driving. And you build that then into your driver training, or you provide some kind of display on the screen to the driver, and you can get significant energy savings. At a first guess, your trains are long haul. You shouldn't be braking so much, so it won't be as high as 16%. That's for a braking duty cycle. But I imagine you'd be able to get 7-8% savings on fuel if you were to enact something like this. And this is us doing similar work with Beijing Metro. In Beijing, they're quite happily. You wouldn't be able to do this in the UK, but in the Beijing, we just put a laptop in the train, and the driver was able to follow our driving trajectory. So we told that showed the driver how to drive. On this trial, we saved 22% of energy compared with the run he'd done the previous day on the same part of the network. 22% of energy is a lot of energy. So work on computational modelling. We've talked about work on switch and crossings. This is interesting, but it's down to a detailed level. So this is a wheelset moving through a switch. It's actually a wheelset moving in a switch in the wrong direction. But we can model the forces in this, and this work's been used to look at particular failure modes in the switch. Also monitoring the train, putting monitoring on the train to measure the track. I think when I was at SAR, people talked about being able to not be able to measure twist and some of the gauge issues and various things. This is a box we've developed to do exactly those sorts of things. This box is about £10,000 worth of electronics, so about 50,000 local currency. And what it does is it enables us to measure from in-service vehicles the track quality. So we have some accelerometers and gyroscopes working in quite a clever way in here. So just to show you a case study, this is the UK, and there's some level crossings here, and therefore we have this is stiff, this is soft ground, and then it becomes stiff again. And what we're doing is we've identified using the measurement train, the national measurement train, we have one of those, that this section in the middle of the track here needs repairing. You can see the mean top has high exceedances, so the repairs between these two dotted lines, track maintenance had to be done. This is using our instrumentation immediately after the maintenance had been done. And what you can see is generally those exceedances have been reduced, but interestingly at this transition zone, from the soft ground to the stiff ground of the level crossing, the exceedances actually got worse. And what's happened there is the track engineers have put in the wrong design, or they've just done it very badly. But immediately afterwards, being able to see that maintenance work has been the wrong maintenance work, and we can see that there's problems there. Interestingly, if I just blow up onto that area, what you can see is that's the same dotted line there of the level crossing. So it means that our data here on the right-hand side of this picture, where the maintenance hasn't been done, aligns between the very expensive measurement train and our data, as you'd hope it does, and this is where that exceedance comes. And then what we can do is we can then start to look at what kind of faults occur there. So this is another example where we have jointed track, and we're able to pick out those joints and the problems with the joints. And we can also, using the same piece of data, look for different types of faults in the same section of track. So this is where the track support has washed away or been removed, and we can find algorithms to find those faults as well. And then over time, we can look at those degradations and we can monitor how they change over time. So if we're running this on an in-service train, we perhaps see the same section of track every day. It means we can log that section of track and see is it getting worse, and then we can do the intervention before it gets to a failure level, rather than waiting to a failure level and having to put a speed restriction on and then rush to do a remedial work. We can put that into an app and various things. Right, so I've said lots. So hopefully what you can see is that in terms of my activity, we have a very large education activity at quite a broad range of levels, and we have a very broad set of research activities, some of which I think have direct application into Saudi Arabia already, without really talking in detail to many of you about these. What's going to happen next, I think, is that I'm going to develop a short report and sort of recommendations which basically say some of the things I've said in the presentation in a shorter way, around some of the ways that we can work together or we can work together over the future. And I'm very keen to develop a three-way relationship between Birmingham, King Faisal University and the industry here in Saudi Arabia, to allow that knowledge transfer and education development to take place. It would be quite nice to put that into some kind of memorandum of understanding, some kind of document, potentially with some targets or some things, some suggested things we might do in it, to make sure that something happens. We've sort of, in passing, spoken about potentially at some kind of rail symposium. I could see an interesting UK-Saudi Arabia rail symposium. There's quite a lot of people here from the arrangements that SAR have with Network Rail, Serco and Freightliner, all companies that we work with in detail. So I could see that might be some way of launching something like that. And then to initiate some research programs and education programs, some really quick wins, some low-hanging fruits type things, but with a bit of a roadmap and a plan for things that we might be able to develop in the future. Thank you very much.
At the end, we would like to thank you all for attending this workshop. We appreciate the participation of the engineers from SAR, SRO, and we would like to thank Professor Cliff for his contribution and in this visit and workshop. We hope that this workshop will lay the foundation for collaboration between industry and institutions like in Birmingham Center, local industry, SAR, SRO, and KFU. At the end, we would like to invite you all to have a lunch, and the lunch will be at the 5th floor of this building, inshallah. Thank you so much.